I can take some problem from you. Oh. I wonder if YouTube was live more than a few seconds. I don't think so. Maybe. I don't know. So how much we can rewind? Actually 0. Interesting. And by interesting I mean annoying. Matrix block sum. Matrix block sum. Let's see. Given a matrix and an integer, return answer where answer of ij is the sum of elements. So we take the squares surrounding every cell, right? Seeing me stream makes you happy? Well, I'm happy about this then. I also hope you will learn something, because I think that's the main purpose. So we have a grid matrix, and it seems that for, let's say, k equal to 1 in a different color, we are looking for every cell the surrounding within range k in every direction. In this case, for this cell I need the sum of numbers there. And there are two ways to do this, slow and fast. I mean, the slowest is to just go through this square. So for every cell I can go through all those rows and columns, and the complexity of this is height of the grid times width of the grid, because for every cell we do something, and this multiplied by k square, because that's size of the size of this square. Actually 2k square, whatever, constant doesn't matter in complexity. So this is the slowest possibility. I think we can also get this if, as we move with square by 1 to the side, we just recompute some cells. Like if later I want to compute it for this cell, I'm taking this new square, then I need to subtract those cells and add these. I just need to figure this out. Then always, as we move with cell by 1, we deal with k updates to add and k updates to remove. Do you have posture hydrate? No, not today. And this is that complexity, which is already, I think, good enough for constraints of around 100. But the best method, without even k, just h times w, is to use two-dimensional prefix sums. For every rectangle ending somewhere, so for every cell like this one, we can pre-compute what's the sum in this rectangle. And then using that we can do something smart, which is, if you're asked about, let's say, this blue rectangle that we're seeing right now, this sum is equal to the sum of all values up to there, so everything here, minus, and now maybe in pink, minus this region, and minus this region. But we subtracted this corner twice, so we need to add it back. Leetcode and binary search difficulties are were adjusted. Binary search.com is more difficult, but I think they want to be that way. In Leetcode, it seems that all hard problems are about dynamic programming, so I don't think it's good difficulty for coding interview preparation. At least, I don't think you should just go for recent problems. We will use two-dimensional prefix sums, and there are multiple ways to compute them. Step 1, compute two-dimensional to the prefix sums, and step 2, for every rectangle that actually square that we want to find the sum of, we will just use two-dimensional prefix sums. Let's use the second step first. Let's do the second step first. Assuming that we created some two-dimensional array with prefix sums, let's just define it. Prefix sum of what size? Height is size of that, width is size of any row. There are at least one, cool. Then this is h by w. Then here there is to do, we need to compute those prefix sums, but second step, answer queries, let's call them. Let's populate answer two-dimensional vector for every row, for every column. And now we need to retype this thing from the statement, all the cells that are within distance at most k. Right, so let's say row 1 is maximum of 0 and row minus k. Mu of h minus 1, row plus k. Sometimes you cannot go by k to some direction, you're stopped by the end of the grid. Same with columns. Like that. And in this rectangle I am looking for its sum, and I could of course here go through all the elements one by one, but instead I need to use prefix sums. And that's prefix sum up to R2C2 minus those two regions on the left and to the top. That's R2 C1 minus 1, C2 R1 minus 1 C2, and we add back some region, the corner, and we need to deal with negative values. Like if this is negative, I shouldn't access that. So if C1 is positive, only then do this, otherwise 0. If R1 is positive, then do this, otherwise 0. And finally, if R1 and C1, then do this, otherwise 0. Step 2 done. Now we're left with step 1. Why not use memset and use vectors? What do you mean? I'm using vectors. Why do I need memset for? No strimping. Okay, I will make one. Thank you. But also it seems that now I'm using the Discord server just to ping about the streams, which is bad. I didn't intend it to be that way. Just recently didn't have time to hang around in Discord. Hi Tony, hi Night. Link command, good call. What's my age? 26. Link. Here you go. Can you do something related to linked lists? I think I can. Yeah, let's do something related to linked lists later. I mean, after this problem. And how do we populate this? One method I like is to first go and always first cell take the sum from above, and that will compute within every column it will compute prefix sum, and then do from left to right, and always for cell take the sum from the left. That's best because it doesn't use any subtraction. So for every row starting from the second one, no, let's do it like that. Prefix here plus equal prefix from the previous row. Not really, this is equal to matrix of row column plus prefix from above. This will compute in every column prefix sum of things above. Of course, again, we need to check if row, then this, otherwise 0. And then we need to go again and take the sum from the left. Column 0. I think that's it. No compilation error, that's something. And I outputted a lot of zeros. Please do two-dimensional Fenwick problem suggested above. No, I won't. In Leetcode? You shouldn't know segment trees for... Oh, yeah, it's a premium problem, so I try to avoid those, even though I have access on my other account. So, you know, for... Oh, you mean, wait, two-dimensional Fenwick tree. For two-dimensional, that's way above coding interview level. I will, yeah, I will again explain two-dimensional prefix sums a little bit. Hash table used in real-time projects? I think so. Yeah, hash table is quite important. It's very basic structure. Didn't populate the answer? You're right, thank you. Your review of Algo Expert. It's good if you like video format of explanations, but it has weak tests. Nine. I guess I need to read this. How much rating on Codeforces for cracking interviews for Google? I mean, if you have 2000, then it should be easy for you. Prefix. Here we shouldn't take matrix again. We once do that. Run code again. All right, and now I will make some drawings to talk more about two-dimensional prefix sums. Then indeed we can take something from linked lists. Is not having the sum occupy every space in the answer vector just filler? Not having the sum occupy every space in the answer. What do you mean? In every space in the answer there will be the sum. Yeah, and now some drawings. Where are we? YouTube. Oh, we are at YouTube. So a short. White. Short lecture on two-dimensional prefix sums. Let's take an example of an array, two-dimensional array. Do I want it to be, what, 3x4 maybe? Yeah, let's go with 3x4. And I will put quite small values so it would be very easy to compute anything. Say 1, 3, 2, 0, 2, 2, 4, 1, 1, 1, 1, 1, 1. Right, we have this. And first, in order to later answer any kind of queries, first I need to compute prefix sums. And what is such a prefix sum? Easy version would be for every row or every column separately to compute prefix sums like this, where this up to here is 1, up to there it's 3, then up to there it's 4. And sure, we can do that, and it will allow us to ask for the sum in any rectangle a little bit faster. Right, so this array of prefix sums within every row, it would look like this: 1, 3, 4. In this next row, 3, 7, 8. 7 is just the sum of that. 8 is sum of everything. 2, 3, 4, 2, 3, 4. And now using this, we can answer queries like, let's answer this one. Let's say, what's the sum of this rectangle? Well, for every row separately, I can say, in this row, I'm interested in those sum in this range, so it's sum of everything minus sum of that. That's 8 minus 3, so 5. That's 5, plus 4 minus 2, that's 2. 4 minus 2, that's 2. So I claim the sum is 9. I got it by taking this sum up to here minus this sum minus this sum, and so on. The complexity of doing this is of height of the grid per query. It's faster than just going through all cells one by one in this rectangle. Then complexity per query is height times width of this rectangle. And instead we have here of height. But we want to be better than that. We want to be more efficient. And for this, we need to compute prefix sums for kind of the whole grid, not just every row separately. And the only thing we can define as prefix sums up to this cell is this thing. So our first step should be to, in some way, compute this array, where it's here 1, 3, 4, but then 4, and what is here for 11 and 13 and so on. So what is 11? This is the sum of everything up to here. No, it is 10, right? Not 11. Yeah, it's 10. And then 12. 12 is the sum of everything up to this cell. So the rectangle spanning from top left corner until this cell. Then it's here 6. There it's what? I guess it's 10 plus 3, 13. And you can continue like that. I will finish this rectangle. 8. Here, this is 13 plus 3, 16. And finally 20. Right. And there are two steps. One is to compute this new rectangle of prefix sums, matrix of prefix sums. The next is to use it. And those are the two parts that I had in my code. First, I computed this matrix of prefix sums, and then I used them with some kind of subtraction and addition back. Alright, how to compute this? One method is with subtraction, but the other that I very much like is where what I did here, where first for every column I compute prefix sums, which I can do in quadratic time. So this, let's move for later. Like, I want to achieve this, but first I did it for every row or column. It doesn't matter too much, but I want to be consistent with my code. Here we add from the previous row, so in every column apparently I did that. Alright, let's focus on the first column. The prefix sums are 1, 4, 6, 8. Second column, 2, 6, 7, 8. And then finally 1, 2, 3, 4. And now it turns out that from this we can very easily get matrix of those prefix sums that we really need. I'm thinking in a different way. Yeah, as I said, there are multiple ways to do that. I like this one because it doesn't involve subtraction here, so we can also use it, for example, to do prefix maximum in this quarter of a grid. Rajuputta, I don't have time now to answer this question. This is why I ignored first time. Don't repeat your comments so much. Okay, what do we do now? What is this 6? This is the sum of those cells. What about this 7? It's the sum of this. Now, if I combine this, if I add it, then I will get the sum of this rectangle. And this is something I need. This is something I should put in this cell, in the final matrix of prefix sums. All right, seems promising. So what about going for always and now adding like this? Before I added in this way and I computed prefix sums. And like that. This is how I got this matrix. And now I'm going to go like that and also compute prefix sums. And it turns out that I get exactly this thing. Because what's here the first row? It is 1, 3, 4. 1, 3, 4 indeed. Then 4, 10. 10 is sum of this prefix, and then 12. 4, 10, 12. 6, 13, 16. Yes. And 16, 20. Yep. So again, this works because here already we keep such prefix sums for every column, and then when we add two such values, like prefix of this and that, we get prefix of, the sum of the whole rectangle. Another way to look at it, even if we have some big matrix, then again, let's look at this. In this cell, we have the sum of all of that. In this cell, we have the sum of all of that. And so on. And so on. When I say we have sum of this, I'm talking about this rectangle on the right. Because 6 is the sum of everything in the initial grid above 6, and above this cell and including this particular cell. So it's like that, and now we see that red plus yellow is this rectangle. Then if we add green to that, we got that, and so on. We add blue, we have this whole quarter of the grid. Santa Hat on main channel. Yeah, I need to change that. I will remove it. I didn't want that. So that's explanation why those twice the nested for loops will work. Where once we just compute in every column the prefix sum. So always for a cell, take the sum already from above. And here in the next thing, we just always take from the left. So always from the previous column. This is why here I add prefix of row and column -1. Column sum, I mean, yeah, I don't know what I said incorrectly, but I first compute column sums, or actually in every column, every prefix sum, and then I use that to actually do something for those top left quarters. And now that we have it, I already made one drawing for that, but again, if you have query about some rectangle, let's say this one, we need to quickly say, in at most 4 operations, what's the sum of elements here. Then what we know is the sum of elements up to this cell. So that's that. We add all of this, but then I want to subtract this. So I add that. Maybe it's better to use green for adding. Add this area, which is just a single value, it's prefix sum up to this cell. And then subtract the prefix sum from this cell, which subtracts this part. Subtract the sum up to that too, because we want to get rid of this region. So we subtract this, and sadly we subtracted this area in top left twice. So we need to add it again. For example, let's efficiently say what is the sum of values in this rectangle. Well, it is the sum of values up to bottom right cell minus sum up to here to subtract this region, minus sum up to there to subtract that region, and plus again this part because we subtracted twice unnecessarily. So let's verify this. It's 20 minus 8 minus 4, that's 8, and again plus 1, that's 9. We got 9 by saying by saying this minus those two plus that, and it should be equal to this rectangle 1 1 1 1 4 1, and it's indeed 9. So the formula seems to work. Do I need to start competitive programming? No, you don't need to start competitive programming, but I encourage you to do that. That was a short lecture on two-dimensional prefix sum. Did you see Colin Gallen's hair? No, I didn't. Is it green or something like that? Now, there was a suggestion about linked lists. And I remember that above somebody indeed suggested a particular problem. Nice linked list problem of n plus constant memory is challenging. Let's see. Write a program to find a node at which the intersection of two singly linked lists begins. Alright, let's do this. Oh, is that the video solution? It is. It's new to me and I want to see how this looks like.
Looking at the merge.
This is merge intervals. It's not this problem. Okay, I thought that for every separate problem they have half a minute introduction video for free.
The first thing, thank you for watching.
Quick poll. Do you think that such videos on Leetcode are useful? Can we do the quick poll? Just type yes if you think the video analysis on Leetcode is useful. Useful. And no, it's not useful for Leetcode. I'm curious, like, if users wanted this feature. Majority of no's. That's interesting. And I'm not saying that like for this particular problem, of course. It just, you know, in general. You know, on one hand, you can say that it cannot. I see some double votes. CSK. I saw double no's. Quality is bad. You know, but so the question is not really, are they useful right now? Okay, maybe I asked a question like that. Okay, people are saying no because the quality is bad. Discussion is the most useful feature of Leetcode. It's some approach to the platform. I believe that binarysearch.io is very heavily relying on the community and such discussion thing, where they actually just provide problems and they want the discussion to happen automatically. To be honest, I want to have the opposite approach with my platform, which doesn't exist yet, where I think like I want to provide the best possible explanation I see for everything, and that's it. Like, so that you would be sure that there is some quality guaranteed. On the other hand, of course, sometimes there might be more solutions. So then some interaction with community is actually useful. If properly made, could video editorials be helpful? Like, they shouldn't hurt. On the other hand, then the platform might start relying on something like that. and then it becomes bad. I will update the link. Updated. Leetcode solution explanations are nice? You mean the solutions written by Leetcode employees? Software engineering stream. No, I don't have any recommendations. I wonder if I did some big poll. Okay, actually new poll again. This is not really that realistic, and it's not that I will make a choice based on that. If I made a course with text explanations only or video explanations only, which is better? I mean, which one I should choose? And please vote text or video. I'm curious about this. Because in my opinion, the perfect combination is to use mainly text because it's superior to read and to skip through, where to do video as well for some stuff that are good to visualize, that are important to be visualized. But what if I wanted to only do one? Oh, the majority is video. Interesting. I think that most programmers in general prefer text stuff. Visual is faster? Is it? Text meaning like a block? Like, yeah, imagine that either you have a choice between explanation like this or a video. But it's either or. You cannot get both. I thought that programmers mainly prefer text. Video of a text. That's a good idea. Text, you have more time to think about it. That's also my approach. I would prefer text as a consumer of such content. I can watch it twice the speed in video. Yes, but still it's hard to find something. I also watch stuff in twice the speed. Code chef like editorial, what do you mean? I agree with Dry Coder. Video makes you feel like someone else did it for you. Illusion of ease. There is something like that. Advanced programmers prefer text. Noobs like us like video. That's one way to think about it. Here you can see bigger chat. No. What's going on? Where is the chat? The chat disappeared. No. Now I don't see the chat. Okay, never mind. Fixed. Sorry that I'm stopping this thing with solving coding interview problems. Just what we're discussing now is very important to me. Sometimes better to see animations like 3 Blue 1 Browns linear algebra videos. Of course. Even text, it should have drawings whenever necessary. So to be honest, I'm usually proud of my editorials and my explanations. Where is some editorial? Do you call? Actually, I was looking for something from old Code Forces contests, but it seems that I didn't make a round in a long time. So yeah, these are some of my drawings. This is quite basic. I think goodbye. Oh yeah. So sometimes I think that with text plus drawings like this one, you can convey kind of everything. Or like this. And then you still keep the advantages of text, where you can search, you can focus on one sentence for 5 minutes and analyze it. I don't know. And the language barrier is smaller if you don't like speak English properly. I think text is easier to understand. Will my platform be paid, free, or tiered? So partially free and partially paid. I guess like Leetcode. I'm very possibly something like you can solve problems for free, but if you want to access the whole organized course, you need to pay. Which generation will have Ericto's platform? Us, our kids, or grandkids? Come on, us, this generation. Come on, man, you're ignoring my chats. When I get tens of messages per minute, I need to ignore some of them. There's no way to avoid that, sorry. I don't have alt account in Codeforces, no. To go with text is to go against the grain big time. Grain or brain? Look at all the websites that are doing this. It's all video, so unless they're totally missing something, text is not preferred by the grand majority. Because, yeah, people seem to switch to video, but also saw complaints in some programmers group that everything now is video. Actually, it's hard to imagine a course on anything with in video format that will give you more information than a book. To be honest, something like cracking the coding interview, it has very good ratio of like amount of knowledge there, amount of stuff divided by the price, because books are cheap. It's a bit strange that courses with a lot of videos are so expensive, like hundreds of dollars. Donations-driven platform would be a better alternative. Maybe. I mean, good question. I don't know. I would prefer to keep my work related to competitive programming to be completely free, and related to coding interviews to just be paid because it's my job, let's say. Okay, I got through the chat. Donations aren't reliable indeed. But I don't know where the launch is. Why you have to choose one while you can provide both, I think? So I thought that text is superior. To be honest, I thought that there should be no videos. Launch date? I don't know, not this month. Yeah, let's get back to solving the two linked lists problem. Cost low so people can afford it. I don't think it will be $10. Hydrate. I will grab water. Okay, let's read the statement and then I'm grabbing some water. This is the link. Write a program to find the node at which the intersection of two singly linked lists begins. All right. So I can go through one list, remember everything in some kind of set, and then go through the other list and stop whenever I have something visible. But your code should preferably run in often time and use constant memory. I believe that with this constraint, it's not an easy problem. It will be a hard problem. Almost always we do the hare and tortoise algorithm. Cycle detection algorithm. This one, where we why is this image not full? Why is it cropped? Where we have one pointer that moves by 2 and the other by 1. So my first thought will be how to use this. But for now I don't see. I'm grabbing some water. Which chair is this? Ergo human? Yeah, ergo human. Where is Camille? Where is he? So I'm hydrating. Don't be a purist, do both. The more you do, the worse the quality is. If you focus on just one style, like only text, then it's better than if you instead spend the same amount of time on both text plus video. It is reasonable to stick to one. But you know, text is easier to maintain, you can correct it, you can improve it. Video, you cannot. It's not a tea, it's apple juice. Somebody said it's just 2 pointers. I don't agree. I don't see how to do it with 2 pointers. Yeah. What did I type? We can start from both and we can move one by one. Then we will be there, then here, and so on. No, that's nothing. Oh, I know, we can measure the length of the... Maybe that's important. With 2 pointers, let's focus on one list. With 2 pointers, one running with twice the speed, we can find length of something, like start with both being here, then one is there, one is there. Well, finally, one is here, one is here. This is the end, so we know that this is the middle. All right, then you have 2 linked lists. For each of them, thanks to knowing the length, maybe this will be helpful. Then you have some other linked list. And you know that their ends are the same. Like this thing and that is equal, and some part here is also equal. You just don't remember, you don't know what part. And now, I think what I will do if they have different lengths is I will try to make them equal with lengths. Because if I get rid of this part of not equal lengths, okay, so let's say that they are of equal lengths. In other words, if this part has the same length as this part, then it's easy to find this common vertex because we just go one by one. Like starting from here, we would go like forward by 1, then we're there, forward by 1, okay, it's the same pointer. So the problem is very easy if we have same initial part for the common one. So let's try to make them equal by finding the length first, and then second, cutting out part of the longer thing. We cannot go backwards, Mr. Extreme. In single linked list, you can only go forward. So CSK correctly summarized the solution. I now see that somebody posted hint in the chat. I don't want hints in first minutes. You could correct video if YouTube finally gets people the tools. But you know, it's not just about YouTube, and generally it's harder to correct video. Like imagine after just months randomly getting back to some old video. Maybe, okay, what about this? If I see a single word that is wrong in a video, I'm not going to correct it. There's just so much hassle for the amount of improvement there. Or I see that I did some sentence is just could be worded differently. In text, you can always improve, and it will take seconds. Can we just insert in a set and so on? We're trying to do constant memory. Like this is the important challenge of the solution of this problem. So step 1 is to find length of both lists, and we will use the hare and tortoise algorithm. Step 2, cut longer list, which just means if one list has length 5, the other 7, look at this thing with length 7 and move twice forward. So you would be at the same distance from the end. 3, just move forward one by one until same node. That's the plan. Another way is to start at A1, go to B1 after reaching C3, do the same from B1. I didn't get that. And I don't want new problem suggestions right now because I'm doing this thing. All right. Find the length of both lists. We need a function for that. Len A is get length of head A. Len B get length of head B. Oh, we don't even need any smart algorithm for that. We just move forward. That's too easy. I guess we can type it here within the class. Get length for some pointer. Pointer P. If this is null, return 0, else return 1 plus get length of the next one, P next. This is just linear, and the way I implemented it's actually a linear memory because of recursion. I need to implement it iteratively. While P is not null, length plus plus, return length. Just use a full word. I almost got linear memory in something that can be very easily done iteratively, and now it's constant memory. I'm trying to understand the comment by onDealer that I didn't understand previously. Start at A1, go to B1 after reaching C3. So do you mean that we should go backwards? Or do you use some smart way? Maybe this is some smart stuff where it just happens. Why can't I draw? No. Like maybe if we move simultaneously with both now, then B will end up here where when A is there. Tips to improve typing speed. There are plenty of free software platforms online. Just practice. There are programs that will teach you how to align your fingers. Maintain 2 pointers and start traversing both the lists. Once one pointer reaches null, we exchange it with the second pointer. And why does it work? Oh, I see. So instead of computing length like this, we can use the fact that when we get to the end with one pointer, the other one, the distance, here is the difference of lengths. So it's like difference of length 1 minus length 2. And now, if at this point you start moving with this pointer and the beginning of the longer sequence, and now we know which one is longer because it's only got here, so it's longer, this is equal that. And now with this we start moving forward, with this we move forward, and like that, when this black mess gets there, we will be here at, so we made the two lists equal, of equal length. I see, thank you. I like my method more, it's easier. It's, I would say, to understand it, it's much, much easier, isn't it? In algorithms, you should try to use some black boxes that you know are easy to do. I didn't even need to think how exactly to find length of a linked list. I just remembered it's possible. I actually thought for a moment that we need the hare and tortoise algorithm, but this is what we need to find the middle, not length. So I remembered it correctly, but I knew that it's possible. And with that, I immediately could say, all right, we can make both lists equal by finding the difference and then moving one of them enough times forward. Cut longer list. So repeat that many times, len A minus len B. If this is positive, then this for loop will do something, and this means that A is longer. So I just need this. Head A becomes the next. Same thing if B is longer. So I'm still going with my solution, but now I understand yours. Head B, all right, now they are equal. Move forward by one until same node, while head A, not head B. Maybe we should make a function to move to next. I use it so many times. Move might be a keyword, isn't it? Do I get this by reference? If I type this, will it work? If I get a pointer, P is P next. Should I type? Huh. Yeah, I'm bad in C++ syntax. I want reference to a pointer or just... Yeah, I don't know. What do I type here to say that I want reference to a pointer? Here ampersand? Or could it also be there? Okay, mostly I see ampersand first, then dot, and then star. All right, thank you. So I want anyway reference to a pointer, and then a lot of times just this. So I struggle with stuff like that because of competitive programming, where we just don't use pointers. Move of head B. And if you don't use something every day, then you forget how to do it. Return move A, and now they are equal. P declared as a pointer to a reference of type this. I will just try the other way around. Use of undeclared identifier move A. Oh yeah, head A. The best kind of programming. Something doesn't work, just try the other possibility and maybe it will work. Right, submit. I didn't care too much about empty lists or anything like that, but it seems that it works. Accepted. I think that's a cool problem. I think that just star p will work. Let's see. It didn't work. So we got some pointer, but here I modify it, but here apparently this pointer is copied by value. So instead we need, what was that? Ampersand here. Explanation, please. I can summarize the solution, sure. The test doesn't look strong enough. Look at the solution. If there isn't intersection, then it dies. Yeah, like I assume that there is intersection. Look at the solution. Brute force, hash table, yeah, but we want constant thing. 2 pointers. Medium solution to an easy problem. I would say that it's medium hard, but well, depends. So I guess they claim to do it faster, but do they really? Let's see. Why did we need to use that? Because it's a pointer, not element of list node. We deal with pointers here. Next instead of move, but it's not that this function returns the next. It's more like it actually moves the pointer, it modifies the pointer. So I think that move is better named than next. How about first finding the length and then position both pointers equidistant from the end? That's what I did. That's exactly what I did. So before I take any new problem, I want to understand this. And I want to see if they do fewer operations that I do. Let's work with this example. So here we have 2 single linked lists. We get pointers to heads of them. We know that they have common end and maybe some common suffix. We need to find that common suffix. And my solution is to go from this one by one until we find null, and this way I know the length of this list. Right? From here the same, we know the length of this list, then I know the difference. I figure out, in this case I would figure out that the second linked list is longer by 3. So from here I 3 times move to the right by 1. Now I'm there. And I start from the beginning of the other list, and I keep going simultaneously by 1 to the right. That's my solution. Let's think how many iterations I can use. Well, first I cover both, so I do that many iterations or operations, and then here I go like that, and I move them simultaneously. Let's say like this if this is the common node. So I can cover each of them twice. Let's see if the editorial does something better. A lot of times they describe something with a single for loop, but actually it's the same number of iterations. Wait, what? The space matters next to list node and star? Are you serious? I'm quite sure it's the same. Your code should not pass the sample? Why? Why? Yeah, it's sum of lengths plus sum of lengths minus twice the common suffix. I agree. But now, their solution, time to understand their solution. They start from start, while PA and PB are not pointing at the same node. Keep moving. So if PA gets to the end, then it starts being head of B, and the other way around. Right, then let's see what happens for this. Or maybe they already say. I want to simulate myself. So now their solution. They start here and they move one by one. There. Finally, it's like this. Then this gets here. So the next thing, we are there. We move on twice. Finally, we are here like that. Then this gets there. So then we have here and here. And that's common. Oh, I mean, not necessarily common. Let's say that this is the first common. And then they move one by one. Like triangle here, triangle there, triangle here, triangle there. Then they have exactly the same number of iterations, just in a way that is much harder to understand. I don't like it. The space matters in multivariable declaration. Are you sure? Can you declare with one line objects of different types? List node star of A, B, C. I don't think it will compile. Unless all of them become pointers. Does it compile? Yeah. So the complexity of both my algorithm and this one is the same. Number of iterations, if you count how many times a pointer becomes the next pointer, it's the same. But what I think is much better in my solution, that is easy to understand. Interviewer will prefer this one. He shouldn't. Like, if you describe what I described, there is no reason for them to not like it. They can say, can you do it with shorter code? But if that's something you're looking for, like, you have some bad like ways to judge your interviewees. I think that it's better to like, a lot of times, if you go to discuss in Leetcode, you will find some one-liner solution. Often I later see that somebody did something twice faster, I mean in twice shorter code, but it actually is the same in terms of speed and complexity, and it just takes 10 minutes instead of 1 minute to understand. I don't think you should learn such solutions. I mean, all right, it's fine to understand it, but I prefer mine. It does compile, list node star. Yeah, but I'm saying, does this compile? Because Gupta suggested it. List node ABC. I would expect this either to create 3 pointers or not to compile. We can also connect the last node to one of pointers and find the intersection using Floyd's algo. To one of the pointers. I mean, if you modify this, I think that what you're suggesting, Nadim, is equivalent to their solution, where they, from the end, they get to the beginning. It does compile? Compilation vote? Okay, I just want to try it. So this, run code. Head A. Okay, so A becomes head A, B becomes head B. I guess this gives compilation error because of wrong types. It does indeed. I'm very surprised that in one line, like with one okay, operation, you can declare things of two different types. Why are we using separate functions to move? Just to save some characters. Like, it's annoying to keep writing head A becomes head A arrow next. I don't like repeating variables. Like, compare this line with this line. Head A is head A next. And then consider that let's say that I went like that, and then I realize, oh, actually I need to change the other thing. I need to change head B to its next. And then it's very easy to do this. And you made a mistake, because actually you should have changed it like that. I don't like repeating variables. For same reason, I think that I++ is superior to I becomes I plus 1. Because here you have double the variable, and if you want to now change it, it's very easy to make a mistake by changing only this to j instead of doing both. So I++ or I plus equal 1 is much better, in my opinion, than this. For same reason, I don't like typing this. Answer is minimum of answer and x. I prefer just to have a function like min self ans x. For sure you saw me using this a lot of times, even though the number of characters here is basically the same. And if you type this as pseudocode, this is also like, this has nice meaning. This means move this pointer forward by 1. Plus I, why not plus I? Yeah, I don't care. I plus I, both are fine. I believe that nowadays compiler will optimize this to be same as I++, if you have good optimizations like O2. I don't think that one of these will be faster for processor, because processor will get the same assembly code. At least I think so. I'm not sure. Compilers are very smart nowadays. How much rating on Codeforces? I think we got exactly the same question and I answered. Can somebody confirm? Was that the same person asking? Yeah, so I think this, that. If it's just a single line and you don't do anything else, then I would say that, I would guess that all of them give you the same assembly code. With proper optimization flags. I don't like pushback works differently than emplaceback. Yeah, maybe that's strange. Pushback for a pair should just do emplaceback, I guess. All right, time to do a new problem. So yeah, I understand why I++ can be faster, and isn't it a case that if you compile with O2, and nowadays like all codes that are supposed to be fast, they will be compiled with optimizations like O2, then it will be the same? But I understand the difference between I++, and I is I plus 1, of course, but compilers should take care of this. Compilers are able to take a for loop over a billion elements and make it in constant time, if they are able to figure out what should happen. Intersection of 3 linked lists instead of 2? Let's think. No, wrong problem here. So somebody asked, what about 3 lists? I think that my algorithm will still work. I have no idea about their algorithm. This should work. So let's say that we have one list, another. Okay, what I would do is find their lengths. Thanks to that, cut the prefix of longer ones. Now assume that all of them are short. And now keep moving one by one. So then we have this, then that, and so on, until all 3 pointers are equal, assuming that you want to make all of them equal. So you're like, if let's say this is the test, like C1 starts here, C2, C3, then and so on, then yeah, we return this. Then my solution still works. Do they have distinct intersections? Like, I assume that they can have some earlier intersection here, but I'm looking for the common endpoint. If for every, I can also for every 2 of them just find their common intersection. Right, let's do something new. Why intersection in example 1 doesn't count a node with value 1? Because we are looking for the same node. We don't care about the values that are there. It's not that we're given 2 sequences and we are looking for the first same value. So it's like the 2 nodes, they have the same value, but they are not the same. Leetcode monthly challenge speedrun? Not likely. It's associative. It depends on how you define intersection. If intersection is just what is the suffix, the common suffix, then I agree. And then we return the first element there. All right, I will check out suggestions by CSK and Lakshay maybe. What do we have here? Given the root of a binary tree, flatten the tree into a linked list. 1, 2, 3, 4. Can you flatten the tree in place with, I guess again that this is a hard follow-up. All right, this is one problem. The other, reverse nodes in K groups. I think I did this one, maybe not. I wonder what happens if you Google, can you reverse a linked list? Because it's kind of becoming a meme, isn't it? I don't know if Algo Expert started that. Or was it maybe author of some language where, no, it was a binary tree. He complained on Twitter that all of Google or something, they used their tools, but he couldn't reverse a binary tree, so they didn't take him. He didn't get a job. It was inverting a binary tree? Yeah, you're right. My streams after you launch your platform every week? I don't know. I didn't plan to stop doing streams. Actually, streams are a great way to promote the platform. Homebrew author? Yes. Only 2 or 3% employees use that tool. Maybe then this is why they didn't accept him. That comes in Algo Expert's ad? Yeah, I think so. Oh, Twitter. Somebody provided a link. Google. 90% of our engineers use the software you wrote, Homebrew, but you can't invert binary tree on a whiteboard, so fuck off. So did somebody actually fact check him? I believe the space complexity is 2 square centimeters and the time complexity is just before lunch. I mean, if you make fun of time and space complexity, then you're doing something wrong. I don't see any fact checking here. I want to find this information about 2 or 3%. Google employees debunked this claim on Quora. Okay. So yeah. By the way, I know how to reverse a linked list. Inverting binary tree. I think they mean just a very easy problem of swapping left and right child. And then you go recursively. That's it. This is what they mean. So it's, I don't even know if reversing is a good word there. It's more like mirroring. It's not that we go now from bottom up. So yeah, we can reverse, or I think this is more interesting. So let's go with this one. Stop repeating your comments. I don't have time to answer everything, and you repeating your comments doesn't help. Has a problem ever been harder by asking to use more memory? I mean, you can always, assign more memory. Yeah, so do this easy problem, but you need to make it in n factorial complexity. Oh no, how to do it? Thank you, CSK, for suggesting. Did I paste the link? Yes, I did. Right. And we will try to do it in constant extra space, because for sure there are many ways to do it in linear space. 1, 2, 5. Okay. After we get from 1 to 2, maybe we should insert 2 here. Because we want to use constant extra space, first of all, we cannot use like recursion. We cannot have recursive stack of length of linear length, because that's linear memory. After I go from 1 to 2, of course I can remember a single parent, but I cannot then go from 2 to 3 and remember the whole path. Maybe we should like swap them or something. Two, three, four. Right, so 1, as a child it should get something that then becomes 2, 3, 4, and then after that comes the right part. So if 1 is connected to some left part, some right part, from this we should get 1, and then something made out of L, and then something made out of R. So if we go recursively from 1 to this left part, it will create this proper part like 2, 3, 4. We should just say that right child of 1 is this. And then we get back and we start with the right part. But if I need to go like this, go down and then do something here, then go up, we need to have this link to a parent. Recursion stack isn't counted in the constant limit? Of course it should be. Like, really? The solution here is to use recursion and have linear stack? Like, who said that? Pensa or Penka. Did you see the solution here? And do they say? Do they have recursion with linear stack? Many times in the solution they use recursion and they say that it's constant. Come on, it's so unprofessional. No, I'm not allowing chat on YouTube. And don't repeat your comments. No, I can keep thinking about the problem, but one of you should check. VKK, you will be banned if you keep spamming. Interestingly, Max Howell answered this on Quora. I want to see it. What's the logic behind Google rejecting Max Howell? Anyone could write a simple package manager. We have author of Cracking the Coding interview tuning in. Maybe I will read this later. If you want a link, then I can paste it again. Okay, VKK, you get banned. What did I want? Yeah. Damn it, I have this issue where I cannot directly copy paste from Google, from Chrome. I need to paste first to something else because it's rich text, it's not just text. Flatten left binary tree, flatten right binary tree, then return root xy, but this is linear recursion. It's not constant extra space. Right, I need, okay. Can somebody check this for me? Do they really do it in constant time or, sorry, in constant memory? All right, Leetcode. There is a constant space solution. Control-Shift-V not work passed in directly. I can try Control-C, Control-Shift-V. Oh wait, does it work? It works! Thank you, Detter, you're amazing. I was aware that Control-Shift-V pastes without formatting, but I thought that this is utterly broken and there's nothing I can do. Whoa, my life just got so much easier. I can now take this link and just Control-Shift-V works. Whoa. Well, then if you're saying this is possible, I will try. I understand that there are links to the solution, but I need to try. But I hope that it's real constant space. We are at 1, we can look at the left child, this thing, and we can reorder it. But if I use recursion, I need to remember how to get here. Maybe I should, for this vertex 2, in some way I need to tell them that I am then your parent. Or we can do some kind of swap. As we go down, we can keep doing some swaps like this. Let's say that, yeah, there is 1. It looks to the left at 2. For a 2, to know that it should get up to 1, I will destroy one of the pointers down. There are pointers to 3 and 4. So I will remember, right? I want to do this iteratively, I think. So I'm destroying this, and I'm leaving aside 3. So I know that next to visit is 3. Then I relink. So for 2, I want to say that your left child is 1. Actually, it's not, but it's parent. I need to remember parent somewhere. And then I go to 3. 3 again, it has 2 children, let's say 5 and 6. So what I do is I destroy this. I'll keep 5 aside. Then from 3, the left child is 2. So modifying a tree like this as I go down, I think I can then go again up, and I will use constant space. What tool is that pen? Epic Pen. But it's not the only one. You can just Google software to draw over the screen. Now, when I get to the very bottom, I need to do something with that. Also, I need in some way to get up from the right child of something. So when I made this 5 here, I need to turn it into 5 and then 6. One idea is that whenever my left child doesn't have any other children, then I say 3, 5, 6. So I put it between me and my right child, and then move down by 2. And because they don't have other children, I think I can store something so that I could go back up. You can put null after every number. That's a linear extra space. I believe that I'm allowed only to modify, for the n pointers that I'm given, I can modify their left and right, and I can add extra constant space, not linear number of them. Does it use same pointers or same values? Shouldn't matter. In this here that I think about this problem, I don't actually think that the nodes have values. It's more like, or maybe this. I assume that they have distinct values. And here a 1 actually just means that this is a node I can refer to. I see, okay, this is node 1. I could also call it Alice. This is node Alice, this is node Bob. And then I relink Bob to Alice. Is it free? I think some parts of it. I don't have the premium version. The result for the O1 solution won't be a real linked list. It will be a tree that won't use either left or the right pointer. Yeah, I agree. This is what we should do. Recursive stack, I think, obviously should count as extra space. So we need to do it iteratively, or with recursion, but of the only constant depth. So not just depth of the tree. If the solution is something like that, then it's very complicated, by the way. I don't know what is Morris preorder. But if something is a Leetcode problem, I should be able to figure this out. Yeah, so I can get back up by using the left pointers, assuming that I went all the way to the left. So what about going to the right? Can I use the same technique? For a 6, it has some left and right. Then its left I will overwrite like this, so I would know that I can get back up. And then when I get up to a 3 from 6, I can compare. For a 3, I see that your right child is 6, left child is 2. So apparently I got from the right child. So I understand from which child I got. But should we also here keep, after going through this right subtree, should I know the last node? You have a vertex, then the left subtree, the right subtree. After you're done with something like this thing, it will likely be reordered to be like that. And then I need to insert this right here. So this goes there. But for that, I think I need you. Or maybe I can go here one by one, just because it doesn't mess up the complexity. Or does it? I think it becomes quadratic complexity. If now I go through the left part and insert it here, yes, then it's quadratic. For every node to the complexity, I add size of the left subtree. It's quadratic for a test like this. And so on, just keep going like this. Then for this node, I will copy all of that. I mean, I will move through that. For this node, I will go through all of that, and so on. So after being done with left part, I should know this last guy as well. Maybe it will be in some artificial way linked, like this guy as left child, it can know this last one, so I could refer to it quickly. I don't know good resources to learning Python. I learned Python, I guess, in university, because I mainly knew C++ before that. Right, let's make a new drawing. And also, let's make this empty. After I'm done with the left subtree, I think that's the format I'm going with. I will turn this into this thing where every node it properly knows its right child. Additionally, the top vertex, so the one that is right here, it has this extra edge, left edge to the last vertex, so that I could insert it here in constant time. How can I insert this in constant time over there? Well, it's just linking this gets right child here. Then I look at this guy, I look at its left child, I destroy this edge by assigning it to null, and then I move from this down there. And I run recursively there. Then the main difficulty is to do this step, so to turn left subtree into that. And after we do this, we need to be able to get back up over there. This is a hard problem, at least the solution I'm constructing here. Yes, I'm doing some crazy relinking to remember that last node. And I don't want to use recursion. I will do it iteratively. Flatten the tree on the left child, similarly on the child. What do you mean? On the right child? Then just add the pointer of the right child head at the end of the left child list, or vice versa. Yeah, but for this I would need recursion. Maybe I need to write this down somewhere. O of one extra space. tail pointer instead of linking first and last node. And if your child is supposed to return to you something like a tail pointer, that it sounds like recursion. Actually, Unacademy recently approached me directly about advertising their products. They have something called Graphy. I don't know what it is yet. I didn't do my research. I heard a lot of bad about Unacademy. So I'm for sure hesitant to accept any sponsorship from them. That being said, I think that people are too negatively, they think badly about anything that is costly. Well, I think everything is just an option. You don't need to take it. So. Right, so as I said, this I want to change into this format with this special left child link. And then after I'm done here, I need to go back up. So for that, when I go here down, for a moment for this guy, its left child should become the parent so that I could go back up. Then in different color. For this guy, after he's done with this left subtree, then we insert it there, then we go here, and then what? I need to get back over there. Now I'm thinking how to get from here there. So what to do after we are done with this part up to there? I need to go like that. So this guy here also, it had this left edge pointing up. But I think now it seems to be a similar issue. Am I allowed to iteratively go like that one by one up? I think that then it's again quadratic. Unacademy is not costly, but people just want everything for free. I think it's costly for India, but it's reasonably priced for learning programming in general. They just want to make money. Every company wants that. If you buy something from, I don't know, Microsoft, Samsung, Nvidia, they all want to make money. Doesn't mean that you shouldn't get their product. Can you please explain recursive approach as well? Recursive is to go recursively to left part, fix it by making it like that, and also this recursion should return to you like the first and the last here. Or maybe, okay, differently. For a vertex, turn the left subtree into this kind of path, turn the right subtree into this kind of path. Then you need to do like 2 relinks, because this needs to be here, so this right vertex, right pointer should point there, and this right pointer should point here. So you do these 2 relinks. Don't need to return the pointer after every recursive call. Yeah, I don't think that's right. The drawing looks like triangle lengths. Maybe subtrees are like triangular lengths. I'm overwhelmed by this problem. I didn't expect something that hard. If it's doable, I'm sure I would solve it in a few hours, but here, yeah, like even this issue right here with doing there, and then in constant time I need to return. I cannot do this in constant time. Are you trying to use Morris traversal to solve this problem? I don't know what that is. I can check though. because this was supposed to be an easy stream. Oh, why Twitch doesn't display the number of viewers? Is it some new feature? Oh, okay, it's displayed. Strange. I needed to go into incognito mode for that. Links are created as successors and notes are printed using these links. Oh, what is this crazy stuff? Wait, what? This is not a tree. Or maybe this is already after some changes. It seems that I just need to learn something new. Use current node's left subtree to replace its right subtree. I guess that's the point. For example, when we consider node 1, since node 2 is on our left, we start putting only node 2 and node 4 to right. And so touch node 5 to the right. Okay, quick try myself. Maybe it's indeed easier than I think. Maybe I just too much think about recursion. For this node, it has something on the left and something on the right. Let's say that this is 1, this is 2, 3, 4, 5. Let's say it's like that. Can I just say that there is 1, then 2, 3, 4, but 4 has a subtree, 3 has a subtree, 5 has like left and right. 1, 2. If those are full binary trees, then I don't see where to put 5. So no, I need to read this. The max number of nodes in the tree is not given. Why can't you use your going iteratively again and again? You need to get constant extra space, so it's hard to solve this problem. Check if current has a left child. If it does not, print current and update it to point to the node on the right of current. But what if it does have a left child? As make current the right child of the rightmost node in current's left subtree. Okay, but how to get it? By the way, is this linear? That's some long code. Morris traversal complexity. Okay, it is linear. Oh, fun. Right. I'm sorry, but putting this solution, I mean, I will not try to understand that. Steven, stop. How do we get the rightmost node in current's left subtree? And why couldn't they first draw a tree without extra links? This is not a tree. First the root, so it's initialized as current. Has a left child. Immediate predecessor to 4 as in order traversal. Okay. Finally 4 is made the right child of 3. Wait, so is it a tree for them? Please move to the next problem. I might do this. Is it just iterative in order traversal? Why just? I mean, maybe it is, but I don't know how to do it. I never thought about making traversals like this in constant extra space. Okay, so I don't like this description because I don't even understand the first drawing. Geeks for Geeks, please save me. They don't even have drawings. They have a video. Right. Do you hear this?
Another
Okay, now you do.
tutorial on Geeks for Geeks. In this video, we are going to understand the program. Have a look. So it's traversal pre as we go to the left child of we continue not null and rent will point. We have another or is traversal pre-order. Hence root will point to 1. Now we enter the while loop as root is not null. We check if root's left child is null. As it is not.
Okay, they don't explain anything in this video. I hoped for some visuals. They just go through code line by line. I can do it myself faster. Is there something with visuals? Because that's actually very important for understanding something like that with relinking.
Hello friends, my name is...
Stack Overflow this. No drawings. But maybe... oh, okay. X is the root, so it is initialized as current. X has a left child, so X is made the rightmost right child of X left subtree. So X is made the right child of B. But how do we get there? Then current is set to Y. So X gets here below B. So okay, I see that. How do I want to modify that? Okay, I can just draw over this. So we look at this and we put everything here over there. So we leave with Y, A, B, and then X gets here. This part is there. Maybe with a different color. This blue part, everything else goes here. So we do this transformation. I will show it again. This. Everything blue is just shifted to the bottom. Right? Yeah, Y, A, B, and then below that there is this. I can find B in linear time. Are you drawing with mouse or pencil? Pencil. Y above refers to Y and all of its children. Oh. So actually we kind of repeat that. Now that the tree has a link back to X, the traversal continues. Alright, then I think I need to learn it on my own some other day. So can we do this first step in constant time, or is it fine that we do it linearly? Damn it. Are you taking suggestions? Not right now. I always say when I take suggestions. Leetcode problem is for pre-order. Yeah, you know, I want to understand any of them, then most likely I will be able to switch to some other version. Yeah, they are doing it linearly. Okay, but maybe there is some reason how in total it's not quadratic. I think this is just a hard algorithm. Then one thing I'm going to do is now log into my premium account, if I remember the password. And I want to check what is the solution provided by Leetcode. The first word says recursion. Actually, I like the visuals with this, tilted L and R. That's very nice. Sure, all of this is easy. This is easy, but this is all recursion. Iterative solution using stack. Yeah, this is n space complexity and x space complexity. This algorithm is slower. What do they mean? They said it's linear. I hope people who say that if you twice go through an array then it's twice slower, they should not write articles. Once you have traversed till the rightmost of some subtree, you will not traverse that length ever again, I think. Let's see. Have a look over this solution. Flatten. I mean, I will not just understand this. While root, if left and right, then do something. Yeah, I will not just try to understand this line by line. This thing with drawings is better. All right. I think that this time, just judging from drawings, Leetcode did a good job. So let's see. Let's talk about the motivation. We always have the easiest of solutions, which is based on recursion, sure. Custom stack, sure. More is traversal. So for 2,6 we do this. So if we apparently here we see somebody without the right child, and then we go like that, and still we need to recursively sort this. Seems to be an easy case. For this tree, indeed, we just start by saying 5, then go, then it's 2, 6, and 6. If to 6 we give this right child 1, then we run recursively for this part. For 6, with left pointing to 44 and right pointing to 1. Also 2 hours passed, so sadly this is the last problem I'm doing today. I will just try to understand this, and that's it. But because it's so hard, and I never heard about Morris traversal, I maybe even will just make a video for this. You find the final node in the rightmost branch of the subtree. Okay, so we have 5. It has 2. We go from 2 as far to the right as possible. And now there is no right child. It may be there is something there, and so on. hookup, it's right child. Okay, then now there's this. Now we do some relinking. This blue guy, it gets this right child. Previously he didn't have a child. And one thing is to rebuild this, and another is to do something with that. How do we deal with the order of this? I'm right now thinking what would happen if 2 had this left part. Like if I video on Morris traversal, actually I just want, I guess, to make a video that would teach how to do things without linear recursion. Move 2 to the right, but 2 should go before 6. So this part, 2 and its left part, it should be between 5 and 6. But it's not that I simply can go there. I can go to 6, do this relinking, destroy that, then go to 2, and run something for this part. So run something for the left child of 2. But then at the end, or maybe we do this single relink and then destroy that and then just run for 2. But that seems quadratic. So is it fine to find linearly from 5 this 2? Maybe it is fine. Let's look here. I do this relink, I destroy that, and now I run recursively for 2. Then for 2, what do? I go to the left child, if there's any. There I find here how far to the right I can go. And here I do some relink like this. The question is, will this part ever be traversed again? Apparently not, because now this part is just the rightmost part in the whole thing, and what I do, and that could cause quadratic time in total, is from some vertex I go once to the left and then a lot of times to the right. But if something is now the rightmost part, because we're just solving this subtree now, this will never be part of that ever again. Is that it? Start from the top again. Yeah, so I'm starting from here. And you're saying start from 5, but 5 is done. We should put 5 here to the left, of course. Say that 5 has a right child of 2, and that's it. And there is this magical thing why complexity is linear rather than quadratic. Not that hard, I guess. Yeah, I don't know if I was that slow because I assumed the problem would be easier. Let's make a proper drawing to see if I understand how to solve this Leetcode problem. We have something here with links to left and right child. and so on. This guy, let's say, doesn't have, so there is no right child for this person. Maybe there are some other parts here, doesn't matter. All right, what I do for the root, I go to its left child, and then here just go down as far as possible to the right. You eventually find this one, rightmost child or descendant of the left child of the root. Then we do this, and we remove that edge. This X just denoted that there was nothing as the right child of blue vertex. Now what do we do? This vertex of course needs to be put there. This is the root, so it moved from here, and now recursively I run starting from this yellow guy. That's the solution. Because I got rid of a single vertex, it's obvious that it will finish eventually, but you might be worried that it's quadratic, because I could traverse a linear time, and maybe I will repeat that n times. That's n squared in total. But this path now that I traversed, it's now the rightmost path itself. But the only thing I can do slowly is that I can look at left child, and then this part will be traversed slowly. So every node will be extra traversed like this by this part only once. So yeah, this again, it deals with some left part. What if it didn't have the left part? Then we would just go by one to the right, and I would do this. But again, this part that was extra traversed, it's still the rightmost path starting from the root. Right, and everything here is done iteratively. I always know the root. I go iteratively here until I stop with some while loop, and then I know the root. I know this blue guy. From the root I can access its right child. I do the relinking like this. I destroy that because I still know the root. I modify left child of the root becomes null, right child becomes the left child, the previous left child. Then we run for that. Yeah, everything is fine. Traversing only twice is confusing. I would say that I would call it extra traversing only once. But I agree that it's not easy. And while investigating ideas like this one, I would just assume that this is quadratic. I would not investigate further. Well, instead, I needed information that, yeah, actually it's linear, and then it's about understanding why it's linear. So this extra linear part where you go from root to left child and then down like this, you can say that this part also paints all those vertices green, and the lemma is that green vertices from now on, they always form the rightmost possible path in your tree. So if this is the remaining tree, the green vertices could only be here. And now again, the process is just that for the root, you look at the left child and you keep going to the right, and something like this you will paint green. No vertex will be painted green twice. Do I know my IQ? No, I don't. And IQ tests are just a measure of how well you solve puzzles that are very similar to math and programming. So, you can boost your IQ by practicing with those puzzles. That's just absurd. Fine. Should I implement this? I guess it's not hard. How much time? 2 hours passed and 10 minutes. Let's do this. Maybe I will fix this while later. Oh, I should do it here. While something, I'm not sure about this condition yet. If you have a left child, if root left is null, if like this, then just root is root right, and that's it. Continue. I just move there and don't change anything. Otherwise, there exists a left vertex. Then we go there. TMP is root left, and while the right child exists, move there. Now we found this blue bottommost right vertex, and we need to relink it like this. Is root right. This is that extra edge. Possibly it points to null. Possibly points to null. I don't see for now anything wrong with that. And then what? What else? Root right is root left. So I relink something for the root. And root is root right. Also root left is null. What, do I return something? No. Is that it? That was easy. I didn't expect to type it in like 1 minute or two. Yeah, I guess that this deserves a video. Painting analogy is great. Almost always when the solution uses words like every vertex visited at most once or twice or anything like that, you can express it as painting something. Okay, after this is painted, it will never be visited again because of that. Always when you have some remaining situation, painted vertices are over there, so we don't go there. Damn, that's nice. It's so short, and I'm sure that somebody at least like 2 or 3 people in the chat already pasted solution equivalent to this one. But you know, looking at it line by line, it's something completely different from understanding it and then implementing. Notice that after you implement a solution, after you understand the solution, you could implement something like this so quickly, but only after you understand what's going on. Was more of learning. We got to use our brain too. So we started with an easy lecture of 2-dimensional prefix sums, and we ended with actually me learning something new. One more time explanation. You mean the explanation about time complexity? Or just explanation of everything? Let's work with a small example. Actually, I want to name them. A, B, C, D, E, F. Let's say that G doesn't exist. A is the root. If A didn't have any left child, we would just continue from C. Okay, but A has something on the left. Then I want to find from this guy the rightmost child here, and I would continue going to the right down as long as possible. Okay, I find it, it's E, and I do this. E as right child, it gets the right child of A. The reason for this is that I want to get rid of A, I want just to continue from the second vertex B, but also I know that the whole solution, let's forget about those red parts. The solution must be A, then some part corresponding to BDE and some part corresponding to CF. Like CF is this, BDE is this. That is the solution. That is the final thing. What's the last vertex here? It's E. So E, as the right child, it gets the first vertex in CF, and this is why we do this relink. Right? And then, as another thing, A right becomes A left. I want to say that this happens. So just simple relinking here. And now we just move on from B. So the remaining tree that we're looking at is B, D, E, C, F. A is already here properly positioned as the parent on B, but in such a way that A looks at B to the right. And now from B we continue. It will go to the left, find the rightmost child, and it will just do this. D will look at E, remove that, then shift B to the B becomes the parent of D, but so that D would be the right child. So we do this. And then we continue with DECF, and so on. Why don't you do small coding games like coding games with viewers? Sometimes I do that indeed. Cool. Thank you all for watching. Let's see if somebody... Oh no, I don't have programming tag. Why, Twitch? Why are you doing this? They randomly remove my tag. Maybe I should Google this issue. Maybe there is a solution there. Yes, science, programming, and maybe some Leetcode. Competitive algorithms. No, nobody. Then if there isn't anything, if there's nobody doing similar stuff, I'm not raiding. Some Linux servers, sir? What do you mean? What Linux servers? It took months to understand this. You did it with seconds. I spent 1 hour and I looked at drawings by Leetcode. So, you know, you're overestimating me. Alright, thank you all for watching. Bye bye. And I rarely play chess, Pneumatic.